Space exploration has always been humanity's greatest ambition, but it is also an arena where the laws of physics are completely unforgiving. Welcome to another episode of History Glitch, where we examine the moments when humanity's operating systems fail catastrophically. Today we are looking at the darkest day in the history of the American space program. Based on the masterful book Challenger, A True Story by Adam Higginbotham, we are going to dissect the disaster of Space Shuttle mission STS-51L. The tragedy of Challenger is often remembered as an unavoidable accident, a sudden, unpredictable failure of complex machinery. But the terrifying truth that Higginbotham reveals is that this was not an accident at all. It was a glitch manufactured by bureaucracy, arrogance, and a culture of silence. The story begins with the design of the Space Shuttle itself. In the 1970s, NASA wanted a reusable spacecraft that would make traveling to orbit as routine as catching a commercial flight. They promised Congress a vehicle that could launch every single week, but to get the funding they had to compromise. The shuttle became a hybrid, a fragile winged glider strapped to a massive external fuel tank and two enormous solid rocket boosters. These boosters, built by a company called Morton Thiokol, were the most powerful rocket motors ever constructed. Because they were so large, they could not be transported in one piece. They had to be built in individual segments in Utah and shipped by train across the country to Florida. And this logistical necessity created the fatal design flaw. Where the massive steel segments joined together, they had to be perfectly sealed to contain the thousands of degrees of pressurized burning rocket fuel. The seal they chose was shockingly simple, two large rubber rings known as O-rings. If those rubber rings failed, the hot rocket fuel would burn through the side of the booster like a blowtorch. For years before the disaster, engineers at Thiokol knew there was a severe problem. A brilliant and stubborn engineer named Roger Boisjoli noticed that after previous shuttle flights, the O-rings were coming back damaged. He saw black soot where the hot gases had bypassed the primary seal, a terrifying phenomenon known as blow-by. Boisjoli realized that the rubber O-rings lost their elasticity in cold weather. When the rubber got cold, it became hard and could not expand fast enough to seal the joint during the violent vibration of ignition. He wrote frantic memos warning management that if they launched in cold weather, the result would be a catastrophe of the highest order, resulting in the loss of human life. He literally wrote those words months before the disaster. But his warnings were buried in paperwork. NASA was under immense political pressure to keep the shuttle flying on schedule. They had promised the world a reliable space truck, but the reality was they were flying an experimental and highly dangerous prototype. The pressure reached a boiling point in January 1986. This specific launch was the centerpiece of a massive public relations campaign. It was carrying Krista McAuliffe, a high school teacher from New Hampshire, who was selected from thousands of applicants for the Teacher in Space project. The eyes of the entire nation, especially millions of school children sitting in their classrooms, were glued to their televisions. But the night before the launch, a severe cold front swept into Florida. Temperatures plummeted to 18 degrees Fahrenheit, freezing the launch pad. Huge icicles formed on the metal launch tower. Back in Utah, the engineers at Thiokol were in a state of sheer panic. They held an emergency teleconference with NASA management. Roger Boisjoli and his colleague Alan McDonald presented their data. They showed that they had never tested the O-rings below 53 degrees. The temperature at the launch pad was going to be in the 20s. Launching at freezing temperatures was essentially playing Russian roulette with the lives of the 7 astronauts. They formally recommended that the launch be delayed until the weather warmed up. The NASA managers were furious. They were tired of delays. One official famously snapped, "My God, Theocol, when do you want me to launch next April?" Under intense pressure from their biggest client, the executives at Theocol did the unthinkable. They told their top engineers to take off their engineering hats and put on their management hats. The executives overruled their own safety experts and signed the launch authorization. The engineers were silenced. On the cold morning of January 28, 1986, the crew of the Challenger walked out to the launch pad, unaware that their fate had already been sealed in a conference room the night before. At 11:38 a.m., the countdown reached 0. The solid rocket boosters ignited. At that exact fraction of a second, the history glitch occurred. The cold, stiff rubber of the right SRB failed to seal the joint. Cameras recording the launch captured a small, ominous puff of black smoke shooting out from the side of the booster. It was the exact blow-by that Roger Boisjoli had predicted. As the shuttle cleared the tower, aluminum oxides from the burning fuel temporarily sealed the hole, acting like a fragile plug. For the first 58 seconds of the flight, everything looked completely normal. The Challenger soared into the clear blue Florida sky. But as the shuttle passed through a layer of high-altitude wind shear, the severe aerodynamic buffeting shattered that fragile plug. A continuous jet of superheated flame erupted from the side of the right booster. This blowtorch of fire pointed directly at the massive external fuel tank, which was filled with highly explosive liquid hydrogen and liquid oxygen. At 68 seconds, the public affairs officer announced calmly, "Challenger, go at throttle up." Commander Dick Scobie replied, "Roger, go at throttle up." Those were the last words ever heard from the crew. At 73 seconds into the flight, the flame burned through the bottom strut, connecting the booster to the tank. The booster swiveled, pivoting its nose directly into the top of the hydrogen tank. The bottom of the tank dropped out, and the liquid hydrogen mixed violently with the liquid oxygen. In a fraction of a second, a massive fireball engulfed the Challenger. The shuttle was not destroyed by an explosion, but it was torn apart by massive aerodynamic forces flying at Mach 1.92 at an altitude of 46,000 feet. Down in mission control, there was a stunned, agonizing silence. The computers froze. The radar screens showed multiple pieces of debris raining down into the Atlantic Ocean. Back in Utah, Roger Boisjoli watched the television screen and felt his world collapse. But the horror of Challenger contains one final chilling detail that NASA kept quiet for years. The crew cabin where the 7 astronauts sat was heavily reinforced. It survived the breakup of the shuttle intact. The astronauts were not killed instantly. They were likely conscious as the cabin continued upward on a ballistic trajectory peaking at 65,000 feet before beginning a terrifying 2-minute and 45-second free fall towards the ocean. They hit the water at over 200 miles per hour, an impact that no human could survive. The aftermath of the disaster exposed the toxic culture within NASA. A presidential commission was formed to investigate the failure. During a public hearing, the brilliant physicist Richard Feynman perfectly demonstrated the fatal glitch to the world. He took a piece of the O-ring material, clamped it, and dropped it into a glass of ice water on his desk. When he took it out, the rubber remained stiff and dented. With a simple glass of water, he proved what the engineers had known all along: the cold killed the Challenger. Adam Higginbotham's book shows us that the Challenger disaster was not a failure of technology, it was a failure of management. It was a tragedy caused by hubris, scheduling pressure, and a bureaucratic system that actively punished people for telling the truth. The cost of this glitch was the lives of 7 brave men and women and the permanent loss of America's innocence in space exploration. It stands as a dark monument to the dangers of ignoring the data. As Richard Feynman famously concluded in his personal report on the disaster for a successful technology, reality must take precedence over public relations, for nature cannot be fooled.